Hello and welcome to another episode of Ken Training. Today's training is going to be on capacitors. The job is working on an indoor blower motor in a residential home. So I visited this home not too long ago, and when I was checking the capacitor for the indoor blower motor, it was reading at that time 5.8 microfarads. The capacitor was rated for 7.5 microfarads. So doing the math on that, that's a 25% loss of capacitance. And then when I checked my amps, actually I wrote it down. Let me just double check to see what that number is. I got an amp draw of 4.4 amps. And the motor is rated at 5.2 amps. So what I'm going to do today is I'm going to change out the capacitor and I'm going to check the amp draw to see if by going from 5.8 microfarads over to 7.5 microfarads, how much of a difference that pulls in amp draw. What I would really like to do is I would really like to have some type of a way to measure the airflow through the fan to determine exactly how much CFM differential there is in just changing out the capacitor. But I don't have a tool in order to determine the exact CFM. So the best tool that I have to do is my amp draw on the motor. So that's going to be my measuring to determine exactly what's going on with that. So that is what today is going to be all about. So for today, I've got a brand new capacitor inside this box. It's a 7.5 microfarad capacitor. Go ahead and just zoom in on this data plate right here. And if you can see this rating on this, you can see the brand name, which is Titan Pro 7.5 microfarad, rated at 440-370 VAC, which is voltage alternating current. Okay, I'll go ahead and pan back. Alright, so when I'm working, so this is a brand new capacitor that's brand new in the box. So when the manufacturer ships this capacitor, they should ship it in a discharged state. This is the one piece of equipment that can kill an HVAC technician even when the power to the unit is off. And the reason why is because capacitors that are operating properly can hold the charge. Some capacitors, let me show you what they look like when they come out of the box. So here, I'm going to take this one out of the box, and even though this one should be discharged, what I'm going to do is I'm just going to take this tool, and I'm wearing some latex gloves, and I'm holding an insulated tool on the insulated handles. I'm just going to short out the two leads. If this capacitor was holding a charge, by doing this procedure, I would discharge any static electricity that would be built up into this capacitor. Now this is a brand new one out of the box and it should not have that, but just to be on the safe side and for demonstration purposes, normally the proper way to discharge a capacitor is to use something like a 100 ohm resistor, put it across the two leads of the capacitor to discharge that capacitor, and then you would wait a certain number of a little bit of time to allow any capacitance to build out at a slow rate. But I don't normally carry around a 100 ohm capacitor resistor, so I just take this and I short it out, as a lot of HVAC technicians do. Alright, so what I'm going to do first is I'm going to go ahead and turn on the I'm at the thermostat, and I've got the fan auto and fan on switch, and I'm going to turn the fan on. Now the camera should have picked that up. Go ahead and come over to me. The camera should have picked that up, and you should be able to hear the indoor blower motor that's on right now. So the indoor blower motor is on, and actually it sounds normal. from all intensive purposes, you would think that everything was normal. So we're going to go ahead and change out this capacitor, and we're going to see if we have any difference on the ohms. I'll show you the furnace right now. Okay, so here we are. I am in front of the furnace right now. The indoor blower motor is running. This is a pane furnace. I'm going to go ahead and gain access towards the electrical and the indoor blower motor. So it's got a screw right here. That's just a hand I don't know what you call it. Just pull that out, lift up gently, and that exposes the front of this. Let me set this to the side. Okay. Now, the electricity comes in over here on the left through a wall outlet. It comes in through this gray extension cord or SO cord, and then it comes in and then enters the unit into here. When I look at my wiring in here, I know that my indoor blower motor is in this section right here. So what I'm going to do is I'm just going to capture a neutral wire, a white colored wire, maybe this one right here, and I'm just going to go to amperage AC on my field piece. I'm going to see if I can capture anything on that. Alright, so that's not a good neutral. It's pulling 0.04. I know that's not a true neutral. Let me grab this one. It's a little bit thicker. I bet you this is a good one. And there you go. So this is now pulling, with the door on, 4.0 amps. So that's the indoor blower motor with the capacitor the way that it is. Now, let me go ahead and, I already know about this particular unit because I touched it not too long ago, but I'm just going to do this for demonstration purposes right now. This, when I pull off this door, the door switch should shut off the fan. Let's just test it out since I'm right here, and it doesn't take any energy for me to do so. And there you go. As soon as I open this panel cover off, the door switch, which is located right here, shut down the indoor blower motor, which is right here. We're going to get you a picture of this right now. Stand by. Okay, so right now you can see the PC board for the furnace. There's the capacitor that I want to change out, and I actually got some notes here that I wrote down the last time I was here. The blower motor was pulling 5.2 amps. The capacitor, I'm sorry, the blower motor is rated at 5.2 amps, and the cap is rated at 7.5 microfarads. Here's the neutral going towards the motor. So let me just do this. I'm going to go to an amperage AC. I'm going to throw it on that neutral line right there, and I'm going to go ahead and hold the door switch in, and I'm going to just see what that is with the door open. And give it a second for it to come on. And with the door off, I'm getting 4.3 amps. So I'm going to go ahead and release that switch, and I'm going to go ahead and unplug the plug that's here on the wall so that absolutely no electricity is here. Pull that off. So now the electricity to the unit is been removed, but I still have that capacitor here, and let's see if I can't show that to you. And there it is right there. But that can, if that, and this capacitor still works. You heard that indoor blower motor still working. So I am not exactly wanting to touch that with my fingers, because that can still have a built-up charge to it. So what I'm going to do is I'm just going to take, I know the electricity is off because I've got the cord pulled from the machine. So what I'm going to do is I'm just going to take my needle nose pliers, and I'm going to short out the existing capacitor. If this capacitor still had a charge, sometimes you get a little spark. This particular capacitor did not spark on me right there. Make sure I do it a few different times just to make sure I got it real good, because I don't want any static charge left in this capacitor. This one didn't spark on me, so it indicated to me that it actually did dissipate. Sometimes you get a little spark. So what I'm going to do now is I'm going to go ahead and pull the leads on one of them. On one of the leads, I'm going to take my my field piece meter, put it on microfarads. There's some backlight so you can actually see. And let's go ahead and check the microfarads of this existing capacitor with one of the leads pulled. And if you can see my meter, that says 5.8. So it's 5.8 microfarads and it's rated for 7.5. We are going to go ahead and pull the other lead out, and we're going to go ahead and pull out this capacitor. And it's just 1/4 inch screw here at the top. And okay, I don't want to lose that screw. Just hold that right there. I'm going to pull out this capacitor and I'm going to put in a new one. Normally you want to put the two side by side, make sure everything matches up, but I've already read the specs on this one. Yeah, tell you what, since you're all in YouTube land, maybe you might want to see this. Alright, so here's your two capacitors. The old one is the one on the right, the new one is the one on the left. So here, the one on the right, you can see that it is a 7.5 microfarad. And where's the voltage on that? There it is, 370 volt. You can see it right there. The new one, 7.5 microfarad, and it's rated at 440/370 VAC. So it absolutely meets the requirements of the old capacitor. And I actually checked out the motor on this unit, and I know it meets the requirements of the actual motor, in case the service tech previous to me actually had the wrong capacitor in there. Mind you, the capacitor is for the motor. So what I did, and I don't want to do this right now because it's a little bit of a pain, but I had to pull off this PC board, put this off to the side, remove a few wires, and then actually pull out the indoor blower motor right here, and then actually see the motor itself so I could read the data plate on the motor to determine what the manufacturer of the motor wants for the capacitor. And indeed, this capacitor, the one that I'm replacing, is correct. So that's why I matched it up and did it that way. So we're going to go ahead and put it in right now. Alright, so I got the new capacitor here, and let's just verify prior to me putting this capacitor in that indeed it is that it's good. So I'm going to take my meter, which is on microfarads right now. Yeah, let me just tie that up right there. You can see the backlight on that. And I'm going to go ahead and touch my the capacitor here, which I already discharged. It's rated at 7.5 and it's getting 7.6. Mind you, the other one pulled 5.8. So we know this one is pulling, it's a brand new capacitor and this is what it's supposed to be doing. So now that we know that, it's a good capacitor, it's pulling the correct microfarads, I'm going to go ahead and put this unit in. So there's a little slot down here, put this like this, come up like that, grab my 1/4 inch screw, and go ahead and tie that in, like so. Screw that in so it's tight, it doesn't wander off on me. Actually feel this, it's actually, wait a minute, I don't like that. I don't want this to walk on me. Well, a motor has a little bit of vibration into it. When I clamp this puppy down, I want this not to do that, okay? I want that thing to be stationary. So there's a little bit of a lip on this. So what I'm going to do is I'm going to pull this back out. I'm going to see if I can't get that lip to get caught in this metal. Otherwise, I'll put some cardboard in there. Any piece of a shim or anything, just because I want this capacitor to be 100% stationary when I walk away. So let me try that. I'm trying to capture that. It's not doing what I want. Alright, hold on. Try that one more time. Let me try that, right like that. Okay. Okay, that's good. I see that difference. So what I did was I pushed it back a little bit just so I could capture that lip, because there's a little bit of a lip on the capacitor. And now the capacitor does not walk on me one way or the other. So if there's a little bit of vibration, as there normally would be in a rotating blower motor, I won't have to worry that this thing is going to drift around during operation or fall out or anything. I want this 100% stationary. We already checked the capacitance. We know it's 100% solid. These particular leads do not make a difference as far as the orientation goes, so I'm just going to land these on right now. There's not like a polarity here. So I'm going to go ahead and land those two, make sure that I'm nice and solidly attached. I can go ahead and plug this in, and if you remember that amp draw, it was pulling 4 amps or something of this nature. I'm going to plug this back in. Let me just get my notes here. So last time I did this, it was pulling, I think, 4.4 amps. Let's go ahead and capture the neutral again. Put my meter on VAC, voltage AC. There's the backlight so you can see it. And I'm going to turn it on. And let's see what happens. 4.2. It's not making a difference. The new capacitor is not making a difference as far as the amperage goes. So that leads me to believe that I'm not really going to have a change in the airflow. But with that correct capacitance going to the motor, that should extend the life of that blower motor. I want to do another test. What I'm going to do is I'm going to put the door back on, and I'm going to see if with the door on what the neutral wire up here pulls, because when I first started out I actually did a test there too. So let me go ahead and put these screws on here. There's a couple of 1/4-inch screws holding this door in place. I'm going to put that on, and I'm just going to capture this neutral wire right here. Oops! And I want to see if that gives me anything. Alright, there we go. And amperage AC, there's your backlight. Here's my neutral wire, and let's see what we got. Now, if anything, it's pulling less amps. So the motor is possibly just working more efficiently, and it doesn't need to pull the amount of amps that it needed to pull with a capacitor that was starting to go out and fail. So it's pulling less amps. I hope that I'm getting at least the same CFM and the motor is just operating properly. Okay, so in this particular case, like I said at the beginning of this video, I wish that what I really wanted to do is I really want to know what the airflow is going through this blower motor in CFM. That's the piece of information that I really would have liked to have known, but I don't have a tool at this time to check that particular CFM. A tool like a flow hood or some other velocity type of a tool. I didn't bring one. I don't have one. So I was using my amperage to try to determine if indeed I could how this motor was going to react by taking a capacitor that's showing 25% loss in capacitance and putting a brand new one according to the motor specifications, which I did, and the amperage went down, leading me to believe that I probably didn't change the CFM, but I changed the efficiency of the motor. I'm assuming that the motor is running a little bit more efficient now, so there's going to be a little bit of a cost savings to this homeowner on how much electricity they spent each hour this blower motor is running. And the motor should run a little bit healthier and may hopefully extend the life of the motor. So this, all in all, this is not bad at all, actually. This I would say that this is a recommended practice. you see a loss of capacitance like this. And by the way, one other thing. In order for you to do this, when you're doing your annuals on your HVAC equipment, you want to shut off the power to that unit, discharge the capacitor, pull a lead, and you want to check that capacitance and then check the rating to see if that is at rating. And you want to keep those capacitors at rating. If you find a capacitor that's not at rating, like in this case a 25% loss, you want to change those capacitors out. So this is something that you should be checking on your HVAC, at least on your annuals. And that's the only way that you would have caught this. When I turned this unit on at the beginning and you just went to a fan on position, from my perspective, everything seemed normal. There was nothing really out of character. The indoor blower motor came on. It's blowing air. The furnace is passing air through it as it's supposed to do. And it actually didn't sound weird. It's the flow. When you went to a supply grill and you put your hand in front of it, the airflow felt appropriate. So those types of indicators, using your sound and using your sense of touch for airflow, were not good tools in this particular case in order to determine if you should change out this capacitor. You need to follow the steps that I kind of outlined there in order to go through to test it, change it out, and all that. So, one thing that you should absolutely be testing for. So that's going to conclude today's episode. I hope you enjoyed this video. If you did, go ahead and click like. You can check out my channel, Ken Training, and I'll see you later.